Hello Eng 1060. In this video, I will cover how to address elements of a matrix. We will first look at one-dimensional matrices, also known as vectors. All values within a vector are assigned an address. This is necessary because we often want to refer to particular numbers in a matrix, such as the minimum or maximum value, or we want to extract only a part of a matrix or vector to form a smaller vector. The syntax to address an element in a vector is to refer to the vector variable name and then in parentheses the index of the element. An example is provided here. The vector A is created containing the values 5 to 40 with a step size of 5. I've created it with manual input so it will be easier for you to identify the connection between the syntax and the result. We can reference the first element of A by stating A bracket 1. So this means the first element of A, which is 5. Likewise, we can reference the fourth element of A by stating A bracket 4, which is the fourth element, which is equal to 20. A unique one is using the end identifier to obtain the last element of the vector. So A bracket end will give us the last element, which is equal to 40. I will now demonstrate this in MATLAB. So we had A is equal to 5 colon 5 colon 40. The first element of A is A bracket 1, which is 5. The fourth element is 20. And the last element, A bracket end, is equal to 40. So it is quite straightforward to reference a vector, whether it be a row or column vector. Since there is only one direction for vectors, the scalar index will give the corresponding element of the vector. However, suppose we want to reference multiple values from a vector. Well, we can do so by referencing them individually and then combining them all into a vector. However, this is a bit tedious. For example, if we had A equals 10 to 60 with a step size of 10, and we wanted to extract the green highlighted values, well, individually A1 is equal to 10, A4 is equal to 40, A5 is equal to 50, and A6 is equal to 60. We can combine all of this into a vector. Let's say B is equal to A1, A4, A5, and A6, which is equal to 10, 40, 50, and 60. However, there is an alternative. That is, we can use a vector as an index for a matrix. So to pull out the numbers highlighted in green, we can reference the vector A with round brackets and then supply it with a vector index of elements 1, 4, 5, and 6. The result will be a vector that contains the numbers 10, 40, 50, and 60. Remember that square brackets are used to create matrices, whereas round brackets are used to address matrices. An example is shown here where again a vector is used as an index to reference the A vector. So we have A is equal to a bunch of values in a row vector. That's created using square matrices. And in the line below that, just shown here, A is being referenced with the index or the indices 1, 3, 4, 5, 7. Remember that 3 colon 5 is equal to 3, 4, 5. If elements of a vector have an index, we should expect that multi-dimensional matrices should have indices as well. We'll now look into how we can reference elements of a two-dimensional matrix. So a two-dimensional matrix has rows and columns. Therefore, the index must identify the row and column that you're interested in. In MATLAB, the indexing first takes the row argument and then the column argument. So for example, if we had a matrix A, we can address the matrix by saying A bracket whatever the row index is, comma, column index. It is important to note that the indices can also take on vectors, meaning that multiple rows and multiple columns can be addressed at once. Finally, the colon operator used as an index tells MATLAB that you're interested in either the entire row or the entire column, depending on if you placed it in the row or column argument. We will see an example of this in the next slide. So here we have a matrix A, which is a 3 by 3 matrix. The matrix is created using the following syntax. A is equal to square brackets 3 colon 3 colon 9 semicolon 10 20 30 semicolon 0.1 0.2 0.3 close bracket. Several elements are highlighted here. We will first look at the blue elements 6 and 9. These can be addressed by stating A is equal to 1 2 colon 3. So the 1 stands for first row, and the 2 3 means the second and third columns. Alternatively, we can say A bracket 1, which is again the first row, comma 2 to the end, which means the second column to the last column. Looking at the orange elements now, 10, 20, 30, we can address that by stating A bracket 2, again this is the second row, and the colon operator here means all columns. An equivalent syntax to get 10, 20, 30 would be A, second row, and the first, second, and third columns. Finally, we'll look at the green element, which is the 0.3. We can address that by saying A bracket 3 comma 3, which means the third row and the third column. Alternatively, we can say A end. This means it will give us the last index of the row and the last index of the column, which in this case is equal to 3 and 3. Ensure that you familiarize yourself with this chart and that you understand all the commands listed here. In this video, we have covered how to address single elements of a vector or a matrix. We also looked at how to address multiple elements of a vector or matrix. And finally, we noted that the colon operator can be used as an index to address entire rows or columns. As a final thought for this video, if AN provides the last element, then what is the result of A first?